Welcome to Lecture 1 of Networks, Friends, Money and Bytes. And today we'll try to formulate and answer the question about our smartphones, especially on 3G, the third generation cellular network, which all use some ingredients of the so-called CDMA technology. So what makes CDMA work for my smartphone? And this lecture video is divided into 5 modules. Take a look at your smartphone, which could be an iPhone, an Android phone, a Windows phone, and you see that it is a symbol of our age of connected lives. It symbolizes a lot of advances. For example, advances in networking technology and services, including wireless networks, the internet, the web, which together with many other technological advances has provided this wonderful device we're holding in our hands today, such as chip design, touchscreen material, battery packaging, software system, business models, and so on. Now we can't help but marvel at this wonderful device. It has become the smart and mobile center of our network lives. And we use it not just for voice communications, not just for making phone calls, but also for what we call data applications, which could be email, web browsing, streaming video, video conferencing, uploading photos, downloading files. And these data applications' performance could be measured, for example, in the unit of bits per second. Now we'll be focusing naturally on the networking dimension of smartphones. And it traverses actually a few different networks. First of all, the radio air interface between your device and, for example, the base station of cellular networks. That's the focus of today's lecture. And then it goes through what's called a cellular core network, which is a wireline, a landline network. And these two together form the cellular network. And then we'll traverse the backhaul of public internet, an IP network, before it reaches, for example, Google's data center that houses the YouTube server, which you might be watching this video from at this very moment. Now, if we look at the cellular network, that part of this story, we see that terrestrial wireless communications dates back to at least 1940s. And since the 70s of the last century, we have seen the growth of cellular networks. From the first generation analog communication to second generation digital communication in the 90s, bridging through 2.5G to the third generation, heavily focusing on data application in the last decade, and now to what people call the fourth generation, one of which is called the long-term evolution LTE networks that's being rolled out in America as well as in certain countries in Europe and Asia. Over the next few years, we can anticipate a lot of LTE deployments. Now, back in the 1980s, some estimate that there will never be more than 1 million cellular users in the US by year 2000. It turns out this was one of those way off underestimates of the proliferation and impact of networking technologies. Later in lecture 18, we will talk about a different kind of wireless networks we also use a lot, the Wi-Fi networks. They started in the late 90s and continues to today. So today's focus is cellular network. And what is a cellular network? Why do we call that cellular? What is a cell? Now I have to first understand that the air interface of a cellular network or Wi-Fi networks use parts of the electromagnetic spectrum. For example, in Europe, the most popular second generation cellular network was called GSM, and the frequency band around 900 megahertz was devoted to GSM. And one of the popular third generation networks was called UMTS, whatever that means. We're not going to be bothered with the acronyms too much today. 1.95 to 2.15 gigahertz part of the spectrum was devoted to UMTS. And these are the so-called licensed band, meaning that you have to pay government a lot of money in order to have the right to transmit. And for example, in the US, the government has collected tens of billions of dollars from wireless operators and sell them the right to transmit in different regions of the country in different parts of the spectrum. Suppose you are given a certain part of the spectrum, for example, between 1.95 to 2.15 gigahertz. You can divide that further into different chunks of frequency bands.